Hi everybody, welcome back to my channel. And I made a video earlier on the basics of statics. That was super basic. Now this video is going to be basics as well because the videos I'm going to make in the future, they're actually going to be more of structural, like trusses and frames, cables. These are going to be tough, so you need to understand these concepts, okay, the basics, to be able to understand the later on videos that I'm going to put. Um, right, so now we're going to learn more about forces. We're going to know what moments are. Now, of course, you might know what they are. You've probably learned them in school, but most of people, they find it difficult. They know the concept, but when it comes to questions, it becomes a bit more difficult. And then equilibrium. Right. So as I already said, these will be our learning outcomes. Okay. So what is a force? We use Newton's second law to define what a force is, just like I did in the basic video. You can watch it if you want. So F equals ma. Okay, that's Newton's second law. That means we can say force can cause translational acceleration of a mass. Okay, right. So force components. Now, not every force you have can be acting on the vertical axis y or in the horizontal axis x. Sometimes you can have diagonal forces. Now, if you want to solve for a question, so a question that's bigger than this, but you have a diagonal force, what you should do, every time you will have to resolve them into and put them in terms of the vertical and horizontal forces. So Fx, which is horizontal, we use Cartesian axis, so x and y, will always be F cos alpha. We use trigonometry here. See, we have created a right angle triangle by just getting the diagonal force and drawing vertical and horizontal forces until they meet. And we have the angle alpha here, which is always between the diagonal force and the horizontal. So fx will equal to f cos alpha and fy will equal to f sine alpha. You can pause the video to try the question. I have made a question in the blue box. It's going to be very simple. I also put in the answers. Now also something else. The lightning in my room is really bad. So I'm really sorry. It's because the sun today is acting weird, okay? And right. So now, how do we go from the component? Okay, let's say you have a particle, you have horizontal force and a vertical force. How do we then go back to the diagonal force? So we get the resultant into only one force, so not just horizontal and diagonal. We use again trigonometry because we see here there is a right angle triangle. We use Pythagoras theorem to find the resultant force, so that's the magnitude of the force. Fx squared plus Fy squared will give you F squared, okay? F is the diagonal force, by the way. Fx is the horizontal, Fy is the vertical. And then the angle alpha, we will find it using, again, trigonometry. So we will do tan alpha, which equals to Fy over Fx. So if you want to isolate alphas, you get only alpha. It will be arctan of Fy over Fx. Right. Now, let's say we have a particle, okay? We have so many forces and we want to turn all that force different. So we have three forces here and we want to get the resultant. That means only a single force that sums up all these three forces. Now we have two diagonal forces and one completely horizontal. We will leave the horizontal because that's already in the form we need it to be. Now the horizontal ones, we will resolve them, okay, to be in no, sorry, the diagonal ones, oh my God, we will have to resolve them to get horizontal and vertical. For example, the 40 kilonewton one, okay, you will resolve it. 4 cos 30, that's horizontal. 4 sine 30, that is vertical, okay? And we always, most of the time, we assume that the force, horizontal force to the right is positive, the upwards force and the vertical force is positive. And then the 25 kilonewton one, we just say, well, 25 cos 45 gives you horizontal and 25 sine 45 gives you vertical. And then you sum up the verticals by themselves and horizontals by themselves. So the sum of the horizontal forces, we sum up the the horizontal forces that go to the right. So 40 cos 30 plus 25 cos 45. Then we have the force that goes to the left. 30, we minus from it. You end up with 22.3 kilonewtons to the right. So direction is important. Sometimes you also have to give direction. And then the vertical force. So the vertical force is just going to be the upwards one, 40 sine 30, minus the downwards one, 25 sine 45. You get 2.3 kilonewtons upwards. So upwards is positive, right is positive. You could pick whatever you want it to be, positive or negative, it's up to you, but it makes more sense because most people use these to be positive. Right, now the forces we got, the horizontal and vertical forces we got from that question that we just did, what if we could combine it back and get one force? We will use now Pythagoras. So the vertical, 2.3, the horizontal, 22.3 squared plus 2.3 squared, which is the vertical. You add them and then you square root it, you get the resultant force, which is 22.4 kilonewtons. If you want to find the angle, which is always the angle to the horizontal, that the dotted lines, you always get the angle going from that way. You do arctan of 2.3 vertical, which is vertical, divided by the horizontal 22.3, you end up with 6 degrees. Now, you static equivalence, what that means. So you can have two diagrams of a particle with set of forces on it, two different forces. Now, they could end up with the same resultant forces, okay? This is where they're both statically equivalent, okay? You also have equilibrium for particles. So if you have a set of forces on one particle, you could end up with the resultant force being 0 horizontal and 0 vertical. So now the particle is not moving, okay, and it is in equilibrium. Right, now moments. This is the interesting part. So moments is, think about it this way. You see the seesaw, okay, seesaw, and then it got a pivot in the middle, and then you go and sit on the right side of the seesaw. And let's say, so yeah, you put on your mass on that seesaw, your weight on that seesaw, which is the weight is the force, okay, your mass times gravity. And if you multiply that by the distance you are on the seesaw to the pivot, then you get the moment. Let's say then someone else, okay, comes and sits on the other side of the seesaw. Let's say their weight is more than you, so their force they apply on the seesaw is more than you, even though the distance between him to the pivot is the same as your distance between the pivot and you is the same, but because his force is more, then he has more moment on the seesaw. There's more moment on the left side. Therefore, there will be a rotational force, a moment force that will go this way, anti-clockwise. Anti-clockwise, we usually put it as negative moment. Clockwise is usually positive. moment, okay? So now there's two things we have to remember, okay? First of all, the formula. So moment equals the force applied multiplied by the distance between the object and the pivot, okay? Now we talk about the two things. Now forces, okay, they only cause translational change. So moving up or down or to the right or to the left or wherever. Moments cause rotational force change, so rotating, not moving in straight lines wherever it's going. It's rotating, okay? Then we also have couple. Now a couple, it could be two forces, okay? They move in, so you see these two lines with F under it, and I wrote on it, so these are the couples, okay? They are of equal magnitude, okay? But they, magnitude, yeah, but they go in the opposite direction. So one is positive, the other is negative, opposite direction. And then you have perpendicular distance between them. That distance we can call it A, okay? No, not A. Anyways, to find the moment on it, we find the force. So because both forces are equal, we just take one of the forces, multiply it by A. A is the lever arm, okay? The distance between first force and the second force. Now, right, what about when we have a single force, okay, a moment of a single force, so it's not a couple. Now, this diagram might look a bit confusing, but these are the type of questions that confuse everyone. Now we have two pivots here, not just one pivot, okay? Pivot A and pivot B, but they're not on the line, okay? We have which is the yellow line, that whole line, okay? We're gonna say it's 100 kilonewtons, okay? 100 kilonewton force acts along the line all the way, okay? Then we have pivot B, and pivot B is 2 meters away from the line. Pivot A, 5 meters away from the line. Now we want to find the moment about A. Let's start with that. So we do 100 times 5, which gives you 500 kilonewton meter, and that is counterclockwise. How do you know if it's counterclockwise? Well, you see the direction that the line is going, okay? If it's going like this, and the pivot is on top here, and so if the pivot is on top, and we're getting the moment, then it should go like this. If the pivot was down, the moment will go this way, which is clockwise. But here we have it anti-clockwise, okay, or counterclockwise. Now on pivot B, it's actually 2 times 100, and 2 times 100 is 200 kilonewtons meter, which gives you clockwise. Now, how is it clockwise? Well, that is because if we go counterclockwise, that will be the moment acting on pivot A. So we have to go clockwise for the moment to be on the pivot B. Now, we can record the direction in two ways. Just now I talked about how you can find the direction that the moment is going. And since I already explained it, all you have to do is the signed convention on the X and Y axis. So if it helps you better, you can draw the X and Y axis on the line and see how the moment will go. Now, 500 kilonewtons counterclockwise, okay, is same as 500 kilonewton meter if you're taking counterclockwise to be positive. So it depends on what you're taking, positive or negative. So you can choose one convention consistently through a problem. Counterclockwise could be positive or negative, so then the other one will be the opposite sign. Now, here is where we get a bit more advanced. Where when we have multiple forces on one body, this is a rectangular body, 2 meters long and 3 meters vertically wide, or I don't know. Anyways, we got the two forces in yellow, 4 kilonewtons and 5 kilonewtons, as you see there. And we only have 3 pivots, okay? A, B, and C on 3 corners, so we don't have D, okay? We need to find the moment on each pivot. Let's start with B. Now, here we are going to assume that the clockwise moment is positive. If we find the distance between 5 kilonewtons and the pivot B, it's going to be 3 meters. So you'll do 5 times 3, that's 15 kilonewton meter, going this way, direction, clockwise. Every time you're going to think like, I don't know which way is clockwise, which way is counterclockwise, think about a clock, okay? Does the clock go 12, 1, 2, 3 like this, or 12, 11? You know, so if it goes this way, that is counterclockwise. It goes like a clock, how a clock hand will go. If counterclockwise is opposite a clock. That's how I actually always remember it. So we get 15, and then we have 4 kilonewtons, which is acting vertically away from the pivot B, and the distance is 2 meters, so 4 times 2. The direction that is going is this way, counterclockwise, so we'll give it a negative moment. So now we have 15 minus 8, that is 7 kilonewton meter, and because it will give you positive, and we said clockwise is positive, that means the direction is clockwise. Okay, now the moment on pivot C. Now, when you have a force that is acting on the pivot and you are finding the moment about that pivot, that force disappears, okay? Because there is no distance. There is no distance between that force and the pivot C. So if you do 5 times 0, it's going to give you 0, okay? That's the force that's acting on the pivot. Now, we have 4 kilonewtons though, and it's 2 meters away, okay? It will give you 8 kilonewton meter, and it's going to go anti-clockwise or counterclockwise, so it's going to be negative. You will get 8 kilonewton meter, and it is counterclockwise. You could also say negative 8 kilonewton meter clockwise, but why have the negative? If it's negative, just do it counterclockwise. Anyways, people do whatever they want. Then we have about A. So 4, okay, will disappear because it is the force is going through the line of action, or the line A, where the pivot is. So, and same thing with 5 kilonewtons. So there is no moment at all on pivot A. The only moment we have is on pivot B and pivot C. So the rectangle can move around, will move around pivot B and pivot C, okay? Now here we can have another a bit more difficult problem, sorry, where we have a couple, but we have 2 pivots. So when the amount of pivots increase, things can be a bit more tricky. But so we have pivot A and pivot B. I know I didn't put them on the right scale, so it's not to scale. Okay, guys, remember that it's not to scale. Now pivot B is so because we say A is the distance from force F to the other force F, which is opposite to it. Well, B is going to be half away from the force F on top, and A is going to be half away from force F at the bottom. So moment on couple is always M, equals F times A, right? If we find the moment about A, so sorry, there is little a and there is capital A, I know, okay? What we do is F times A, but the force on B, you get F times half A plus F times half A, okay? Because then you have the force on top and the force on the bottom acting on it. So what do we learn from this? It is that the moment on the couple, actually, the pivot point is irrelevant. It don't matter if you have two pivots. You will always get the same answer, okay, on either pivots. It only depends on the magnitude of the force and the lever arm, the A, little a, okay? Anyways, so now we are going to talk more about line of action. I have mentioned it a couple of times in this video now, so let's actually understand what it is. So it's actually very simple, but most people complicate it. It's just a straight line that goes through the force, okay, that is acting, and it's an infinite line. It doesn't have a distance. It just shows you where the force is acting on. Now, on the right diagram, you've got pivot A, you got two forces, F1 and F2 acting on it. When you get the resultant force, it's going to go downwards. The line of action will go down through the resultant force. Whenever you have the resultant force going through the pivot, okay, then the moment will always going to be zero. Just like the remember that question we solved, we had the moment on pivot A, I think it was pivot A, 0. That's because both forces were the line of action of these forces went through the pivot. So that is something to always remember. Now, how do we locate the line of action if we have parallel forces? We will have to find again resultant force. Now, if we find, so because we only have vertical forces acting on this line and you have a pivot A, you've got F1 and F2. When you add them up, you get R. And R is in the yellow line, you see. But how do we know, okay, the distance between R and the pivot? We use moments. So we have only one pivot here, and we're going to find the moment about that pivot. And we have the distance A's and B's, F1 times A plus F2 times A plus B, okay? The reason it's A plus B, because that's the full distance between F2 and A. They both cause the same direction, the same clockwise effect. So we're just going to add them up. We will end up with the resultant force times x, and x is the direction, okay? So when you get the moment, you put moment equals the resultant force that we already found on the sum of F vert, and you want to find x. That is, we use algebra and we just do moments, the moment about A, sum of the moment about A divided by the resultant force. You find the distance. So now you know where the resultant force is, and you find the distance. So now you know that the line of action goes straight through R, okay? So if you have a moment, the resultant moment, but uncoupled, the line of action becomes irrelevant, because on the moment, a couple, okay, will always have resultant moments, but no resultant force at all, because you've got two forces going on the opposite direction with the same magnitude. They're going to cancel each other out. So it don't matter. The line of action almost don't exist, and instead we show it in terms of moment. So which direction, rotational direction, clockwise or counterclockwise it's going. Right, so now we are going to think of a body that is in equilibrium, and so therefore the resultant force is going to be 0. What if we have the forces on it and some forces are unknown? How do we find them? Well, we use 3 equilibrium equations. We got the sum of the horizontal forces must equal 0, the sum of the vertical forces must equal 0, and the sum of the moments must also equal 0. Right, now we have this rectangular body. It's 3 meters long, 8 meters wide, and then there is a pivot B, which is 2 meters away from the end. So you got 6 meters between pivot A and B. Okay, we got the following unknowns: AH, which is the horizontal force going through pivot A, AV, so that's the vertical, and BV, the vertical force going through pivot B. Okay, now first of all, let's do the horizontal forces, the sum of the horizontal forces. So that means we have to have 4, okay, plus AH must equal 0. Therefore, AH must equal minus 4 kilonewtons. So actually it's 4 kilonewtons to the left. Now the vertical. Now the vertical must equal 0. So if we have AV plus BV minus 6, okay, because 6 is to the down, must equal 0. So we have AV plus BV equals 6. Now that's not good because we can't find both of these variables. Therefore, we need another equation to form a simultaneous equation. That's why we're going to take moments about the pivot. So we could pick either pivot A or pivot B, and they should be equal to 0. So if we're taking pivot B and we're taking the moments about it, that means BV, the force BV will disappear because that force, the line of action goes through the pivot. Now we have the other forces. We got negative 4 kilonewtons, okay? That is going to also disappear because the line of action goes through the pivot. Now we only have AV, 6 kilonewtons and 4 kilonewtons. Let's start with AV. If we have AV, okay, and we multiply that by 6, we get 6 AV. And in this one, we are going to take the counterclockwise to be positive, okay? So we're going to have negative AV times 6. And then we are going to look at the other forces now. So we have 6, the yellow 6, which is up, you see it, multiply by 2. Now that is also clockwise, so that is negative 6 times 2, so you have negative 6 AV minus 12, okay? Then we find the 4 kilonewtons, that is multiplied by 3, and again that is going to be clockwise, so it will be minus 12. And the total gives us that 6 AV equals minus 24 Newton meters, so AV must equal to minus 4 kilonewton, so that is 4 kilonewtons downwards. Then we already made the equation from the sum of the vertical forces, AV plus BV equals 6. Using that, we replace the AV with the minus 4. We end up with BV equaling 10 kilonewtons upwards. So as you see here, we used 3 equations to find the missing numbers. So yes, that's all. Thank you so much, guys, for watching, and I really hope this helped you understand some important things with the starting course of statics. I'm going to do more videos, and the next video is going to be about um, degrees of freedom, I think. I'll see, I'll look at it. And then after that, we'll do trusses and more advanced stuff. Okay, so this is just the beginning. And yes, so see you guys later. Bye.